Hello everyone. Today we begin our lesson on the FineBI interaction. In FineBI, the main interactive functions we provide for users include linkage, drilling down, jump and filter components. After that we'll cover other components, such as text components, image components, tab components and web components. Finally, we'll briefly introduce some commonly used functions of these components. Let's first take a look at what linkage means. As you can see, when we click on a specific part of the donut chart, for example on direct marketing stores, the other components automatically filter the data related to direct marketing stores. The bar chart will then only show the sales figures for the stores, and the same applies to the other component. This is what we call linkage. Clicking on an item in one component triggers corresponding changes in other components. Of course, we can also configure certain components not to follow the linkage. For instance, if we don't want the regional sales to change accordingly, we can adjust the linkage settings during the dashboard interaction setup. There are two ways to configure linkage: default linkage and manual linkage. Default linkage occurs when multiple components use the same data table, or when the data tables they use are related. In such cases, the system automatically sets up linkage between these components. For example, if the store table includes a province field, and the supplier list table also has a province field, the two are linked through the province field, and default linkage will be set between them. With default settings, clicking on one component in the dashboard will cause all other related components to follow the linkage. If you want to modify this default linkage method, we can configure it specifically. Let's open a dashboard to take a look. Here is a dashboard we built before. When we click More, we can see that linkage is enabled by default. This is because there is a relationship between the components, or they are using the same data table, so linkage is automatically set. Similarly, we can also set up manual linkage. For example, let's say we want to configure linkage between the sales list and distribution of sales. We can click the drop-down here to find the linkage setting. By default, it is set to bidirectional linkage. If we don't check this option, there will be no linkage. To enable linkage again, we simply click to reselect it. Additionally, we can edit custom linkage. Here we can see the fields on which the linkage depends. If we want to modify these dependent fields, we can do so accordingly. Clearing linkage can be done in two ways: clear all linkages or clear linkage for a single component. If you don't want any linkage between components and prefer to view the overall dashboard effect, you can click Clear All Linkages here. If you only want to clear linkage for specific components, you can select Clear Linkage Item. For example, if I am currently viewing the individual linkage effect for furniture, and no longer want it to be linked, I can click Clear All Linkage to remove all linkage effects. Similarly, if I don't want to show the linkage effect between percentage of sales and sales list, I can click Clear Linkage Item here to remove the linkage effect we just observed. Next, let's dive into a hands-on exercise to learn more about linkage. Let us create a new folder and name it Interaction Topic. Then we will create a new analysis subject and choose the local Excel. We'll select the first 3 data tables as we'll need them later and click OK. Now we can see the 3 specific tables. In the store information table, we can see store codes and the corresponding store names under specific provinces and cities. In the sales information table, the available fields don't fully match our analysis needs. We want to see data related to provinces and cities, and the commodity codes aren't the specific information we're interested in. Instead, we want to know the commodity categories and their specific names. Therefore, we can perform a left join between these 2 tables, using the store code as the public field. Similarly, we can continue to perform a left join with product information table, using commodity code as the public field. This way we can obtain the product category and product name, containing all the information we need. We'll start with the sales information table and perform to left joins. First, click left join, choose the store information table. Select all fields and click OK. This merges the data based on the store code field. Next we'll merge with the product information table. Select all fields and click OK. This merges the commodity category and product name from the product information table, using the commodity code field. Next we need to calculate the gross profit amount. Click Formula column. Rename it to gross profit, and define it as sales minus cost amount. Click OK and save the dataset. Now let's create our first component. We want to analyze the sales performance of different products, and filter out the top 10 products by sales. Rename this component to Sales Top 10. By default, select a grouped table. Choose the merged sales information table as the data source. Under Dimensions, add product name. And under Indicators, add sales. In the drop-down for product name, set a filter condition. Select the top 10 products by sales. Under product name, choose descending order to sort by sales. Optionally format the sales amount values to display in thousands. This completes the grouped table, showing the top 10 products by sales. Next, let's create a component to show the sales proportion by product category. Rename it Product Category Sales Share. Select a pie chart to visualize the proportions. Map product category to color. Sales amount to angle. This will automatically calculate the proportions. We can add labels to display both the sales amount and commodity category. Adjust the radius settings by setting the inner radius to 0. We can convert it into a standard pie chart, and both is OK. Now we can clearly see the sales distribution across different commodity categories. Next, let us create a component for gross profit margin analysis. Rename it to Gross Profit Margin Analysis. Since there is no existing field for gross profit margin, we need to add a calculated field. Gross profit margin is calculated as total gross profit amount divided by total sales amount. We'll use an aggregate function. SumAgg for gross profit amount. Divided by SumAgg for sales. Use a grouped table to display the results. Under Dimensions, add province. Under Indicators, add the calculated gross profit margin. Sales, gross profit amount, and cost amount. Sort the gross profit margin in ascending order. Finally, let's create a 4-level drill down level. This allows us to drill down step by step to explore the details. Drag city under province. Then sequentially drag store name and product name under city. Now we have created a drill down level, from province to city, then to store name within each city, and finally to product name within each store. Using this level, we can explore the data layer by layer. For example, if we find that Hunan province has the lowest gross profit margin, we can drill down to see which city is causing the issue. Click on Hunan province to view data for all its cities. If we notice that Changsha City has the lowest margin, we can drill down further to see specific stores in Changsha. If we find that Mei Shu store has a negative gross profit margin, we can continue drilling down to view the gross profit margin of all products in that store. For instance, we might discover that Dove chocolate has a negative margin. This demonstrates how the drill down functionality enables detailed layered analysis. Now, let's proceed to create a component for the count of key supplier records. Name it Supplier Record. Switch to the data view and add a new data source. Again, select the local data source option. Choose the supplier list and click OK. We can save this step as well. Next, we'll continue to create the new component. In the Dimensions section, add City and Important. In the Indicators section, add Count. We can expand the row header nodes to view the detailed supplier record table. Now that all our components are set up, we can start building a dashboard. Click Add Dashboard and place all 4 components we've created into it. Then we can proceed with layout optimization and styling according to your preferences and requirements. Next, let's review the specific requirements for this exercise. The exercise requires us to configure linkage settings between the following components. Firstly, we need to use the supplier list worksheet to create a pivot table and set up a bidirectional linkage between the product category sales share and sales top 10 components. However, for the linkage from product category sales share to gross profit margin analysis, we'll set it as a unidirectional linkage. Then we'll configure a unidirectional linkage between the gross profit margin analysis component and the supplier record. The reverse interaction is not allowed. Let's proceed with these specific settings step by step. Bidirectional linkage means, for example, if I click on a slice of the sales proportion chart, it can filter the relevant data in the sales top 10 component. Similarly, if I click on a row in the sales top 10 component, it can also filter the specific data in the proportion chart. Unidirectional linkage, on the other hand, means that clicking a slice in the proportion chart filters the sales top 10 data, but the reverse does not have the same effect. Now in the dashboard, let us first configure the bidirectional linkage between the product category sales share and the sales top 10 components. Click on More. Since they use the same data source, linkage is enabled by default. We can choose to cancel it first. This will disable the default linkage setting. First, select the proportion chart, click the drop-down, and choose Set Linkage. It currently shows linkage disallowed since we just cancelled it. Click to enable it again, and we'll have a unidirectional linkage from the proportion chart to the sales top 10 component. Click OK. We also want reverse linkage. Now select the sales top 10 component, click Set Linkage, and enable it here as well. Click OK. Now if I click on the snacks category in the proportion chart, the sales top 10 component will filter to show sales data specifically for snack products. Similarly, clicking on a specific product in the sales top 10 component will trigger a corresponding effect in the proportion chart. If we click Clear All Linkages, the original unfiltered components will be restored. Additionally, we need to set up a unidirectional linkage from the sales proportion chart to the gross profit margin analysis component. Select the proportion chart, click the drop-down, and choose Set Linkage. We want to enable unidirectional linkage to the gross profit margin analysis. Click OK. Since this is unidirectional, no further linkage setting is required from the gross profit margin analysis back to the proportion chart. As we can see, here the gross profit margin analysis cannot trigger linkage to the proportion chart, but the reverse works. Next, we need to set up a unidirectional linkage from the gross profit margin analysis to the supplier record table. Select the gross profit margin analysis. Click the drop-down, and choose Set Linkage. We want to enable unidirectional linkage to the supplier record table. The custom field will use the dependency fields like city and province for linkage. Click OK. This sets up the unidirectional linkage from the gross profit margin analysis to the supplier record table. For example, if I select a specific province here, the linkage will take effect. We can clear the linkage item to undo the operation. But reverse linkage is not possible. And with that, we have completed the demonstration of both unidirectional and bidirectional linkages in this exercise.